So this is an IGCSE exam question, rather nice one. And what we've got here is a diagram of a rectangle that's been bisected diagonally. So we've got two triangles, and we've got to, given this information, which is repeated down here, but also on the diagram, we've got to A, show that x squared minus 10x plus 18 equals 0. And B, we've got to solve x squared minus 10x plus 18 equals 0, giving our solutions correct to three significant figures, showing our working clearly. Okay, well, let's look at the examiner's remarks. And it says that relatively few students could proceed beyond 2 marks, and many didn't get this far. So people really did struggle with this. It says in part A, students either started off by using 10 minus x, so these presumably are the students who could tackle this question, so they either used 10 minus x or they used root 8 squared minus x squared as the width of the rectangle. Those using the former expression were generally more successful, so this 10 minus x was the best strategy to use. Writing root 8 squared minus x squared as 8 minus x was a common error. Okay. Many convincing solutions were seen though. In part B, there was a clear requirement in the question to show working clearly. But that meant that any candidate who gave the correct answer without any working scored no marks at all. And they say finally the most common mistake was minus 10 at the start of the formula. So those are the examiner's remarks. Okay, let's give it a go. So the very first thing we're going to do is we're going to just complete the diagram a little. So the diagram shows a rectangle. You've got x centimeters along here and 8 centimeters along here. But what we really need to know is what is this dimension here. Okay, and we can see that it's a right-angled triangle. So there's a couple of ways of completing this. First of all, we want an expression for this, let's call it the width. Well, what we can do is use this information that the perimeter of the rectangle is 20 centimeters. So this is the key fact here that we're going to use to get an expression for the width. So if the perimeter is 20 centimeters, then if we subtract, let's work on A then. So if we subtract from 20 the two lengths here, so that's going to be x and that's going to be x as well. So it's 20 minus 2 times x, or 20 minus 2x. Then that's going to be twice the width. So 2 times the width. And that's where this 10 minus x comes from, because now we've got an equation. If we divide through by 2, we'll end up with 10 minus x equals the width. So we can say that this, let's put it over here, this is 10 minus x centimeters. The other thing we could do is we could say, instead of going for the perimeter straight away, we could say, okay, this is a right-angled triangle, therefore I can use Pythagoras. So by Pythagoras, this side squared, taken from this hypotenuse squared, will give me this side squared. Therefore this side must be the square root, let's put it here, the square root of 8 squared, the hypotenuse squared, minus x squared. So that's another way of finding an expression for the width here, or the height, if you like, of the rectangle. Okay, well, if we start with this one. Let's just think about how we would use this now. We want to use this information that the perimeter of the rectangle is 20 centimeters. So that must mean that x plus this side, root 8 squared minus x squared, plus another x, plus another 8 squared minus square root of 8 squared minus x squared, will give us the perimeter. So if I use this here maybe, just to save space, if I say 2 times, because we've got 2 of these widths, plus 2 times the length, which is x, I get this expression equal to 20. And now, again, I can divide through by 2 to leave me with 8 squared minus x squared, square root of all of that, plus 2x minus 20 equals 0. So just subtracting 20 from both sides to bring that over, and rather than 20, what I should have done is divided through by 2. So 2 divided by 2, which is 1, and 20 divided by 2, which is going to be 10. So I can now bring all these over to the right hand side, so that I've got now root of 8 squared minus x squared equals, well, that was minus 10, so it must be positive 10, and this is plus x, so it becomes minus x when I bring it over to the other side. So all I did there was I subtracted minus 10 from the left hand side to get rid of the expression here and make it appear on the other side, and I subtracted x from this side, and therefore I had minus x on that side. So now I've got the square root of 8 squared minus x squared equals 10 minus x. Well, to get rid of the square root sign now, I can simply square both sides. So I've now got 8 squared minus x squared on the left hand side, and on the right hand side I've got, well, if I think of this in 2 brackets, I've got 10 minus x times 10 minus x, which would be 10 minus x squared. So expanding my brackets, I've now got 100, so that's 10 times 10. 10 times minus x gives me minus 10x, and minus x times 10 will give me minus 20x, and then minus x times minus x gives me positive x squared. Okay, so now I can resolve it. So my minus x squared can go over onto the right hand side to join this one. I'm also going to just swap it around as I do this. So I'll end up on the right hand side with, so I'm adding x squared, in other words, 2 x squareds on the right hand side. And I'm going to do the same with this 8 squared. It's going to be minus 8 squared, so minus 64. But let's just do my x term here. So minus 20x. And it's going to be 100 then minus this 8 squared, so minus 64. That's going to be plus, then 100 minus 64 is 36. Okay? And then I've got everything over to one side, therefore that equals 0. So just a bit of rearranging there to get myself a nice quadratic. Now I can see that everything divides by 2 again, so dividing through by 2 I get x squared minus 10x plus 18 equals 0 divided by 2, well that's 0. And x squared minus 10x plus 18 equals 0 is what we wanted to, is that which needed to be shown, which was to be shown. So there we are. We've done the job. But the interesting thing about this question is I think that's the hard way to do it, as was suggested in the examiner's remarks. So we're going to now use the other expression that we got, which is this one, 10 minus x centimeters for the width, instead of this root 8 squared minus x squared. So what would happen if we did that? Okay, so this time I didn't get that by Pythagoras. I got it just by reasoning out what the perimeter must be. So I'm going to use Pythagoras now. I'm going to say in this triangle, where this side is obviously x, so by Pythagoras, and it's worth writing that down so the examiner knows what we're doing. So by Pythagoras, we've got 10 minus x squared, so that's the width, plus the other short width, which is x squared, equals 8 squared. So that's given us our formula. We can now expand this, move everything onto the left hand side, and we should again get x squared minus 10x plus 18 equals 0. Let's have a go. So again, this is two brackets multiplied together, 10 minus x times 10 minus x, giving us 100, minus 10x and minus another 10x, so minus 20x, plus x squared, minus x times minus x is x squared, plus another x squared, then this x squared that we had left, equal to 64. And you can see it's going to resolve very similarly to the one over here. So we've now got 2x squared minus 20x plus 100 minus 64 is plus 36 equal to 0. And again, divide through by 2 and we get our x squared minus 10x plus 18 equals 0, which was to be shown. So I think you can see that there was an easier way of doing it, but both methods should produce the same result. So we've shown that x squared minus 10x plus 18 equals 0. Now in part B, so I'm just going to give myself a little bit more room by removing this one. Okay. In part B, we're asked to solve x squared minus 10x plus 18 equals 0. And it says give your solutions correct to three significant figures, which strongly suggests to me that we're going to need to use the quadratic formula because they're expecting a decimal answer. But it's a good idea anyway to start a question that tells you to do this by finding the discriminant. If the discriminant, which is b squared minus 4ac, part of the quadratic formula, if that is a square number, then we could use factorizing. So we could factorize this and that would give us the two solutions. But in this case, I'm expecting to have to do the whole thing. Nevertheless, I'll start with the discriminant. So if I write down that the discriminant equals b squared minus 4ac, all I need to do is work out what a, b and c are. So a equals 1, b equals minus 10, and c equals 18. So the discriminant equals b squared, well that's 100, minus 4 times 1 times 18, well that's going to be 4 times 18, so that's 72, which gives me a discriminant value of 28. So there we are. We can see that we've got a nice whole number, so there are solutions, but it's not a square number, which is why we're going to use now the quadratic formula. So the quadratic formula is x equals minus b, so minus b is minus 10, so that's going to be positive 10, plus or minus the square root of the discriminant. so b squared minus 4ac, which we've already worked out is 28, all over 2a, so that's 2 times 1, in other words, all over 2. And that gives us, let's see, using our calculator, okay, 15.29, okay, 15, and I'm just going to go dot 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 because 4 decimal places here is clearly going to give me 3 significant figures. So I just need to go as far as I need to for the accuracy that's required here, and that's going to be plenty to get that accuracy. Okay, so divided by the 2 here, and that's if I've got 10 plus the root of 28 over 2. The other solution is going to be, let's just put a comma here, let's see, okay, and it gives me 4.7084 dot 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 over 2. So if I halve these values, my answer is 7.646. So I'm rounding up 645 dot dot dot, but 646 to 3 significant figures. Or x equals, and what have we got? 2.3542, so 2.354 to 3 significant figures.